Hello and welcome back to Principles of Accounting 2. I am still your host, Dr. B. Appreciate all of you taking the time to join me today to talk about this very important concept called process costing. Hi, Maria. Appreciate you being here. Process costing, similar to what we talked about last week, is a type of manufacturing where we continuously process. We continuously make the same thing over and over and over again. A lot of it. Same thing. That's what process manufacturing is. It's different than job order costing, which is what we talked about last week. It has some similarities. We're going to talk about those things. Before we jump into today's discussion on process costing, I do want to call your attention to the classroom. We are here in Module 1, week number 4, and we're on Chapter 20. For this week, you have the Chapter 20 quiz, which I would like you to take on Thursday, ideally, at least for the first time. Then if you need to take it a second time, you do that before Sunday. If for whatever reason you're late with something, I probably sent you a message today. If you missed the first discussion in the first week, or if you missed a quiz or an assignment from the past 2 weeks, that's a problem. Don't miss stuff. Okay, don't be late with stuff. Very, very important that you make sure that you submit whatever it is every single week. Okay, I need you to be on time. Really, really important. But moreover, I need to make sure that you do the work. There's something due in every week. Okay, so for these past 4 weeks, stuff due. One thing for each chapter, right? So just make sure, go back and make sure that you submitted everything. Okay, very, very important. I don't want you to miss points because you forgot to do something. Right? That's my spiel. I'll get off it. Okay, let's talk about process costing. We're here in week 4, chapter 20. 2023, spring, I know. Crazy. Okay, let's talk about it. And of course, as always, for those of you on the call today, please make sure you unmute your microphone and ask your question anytime that you don't understand something, or if you need me to explain something again, or whatever. Add some commentary. Totally fine. Just feel free to unmute your mic and ask your question. Appreciate it. Okay. Last week, we talked about job costing. Remember, job costing, everything was specific to the customer's order. We talked about manufacturing cars. Each car was a job based on a customer's order. Highly customizable, low standardization. We don't make a whole lot of them. Okay, that's job costing. We talked about that last week. This week, we're going to talk about process costing. Process costing is we make the same product over and over and over again. It's identical. Low-cost products. Think of a manufacturer that makes bottled water. Okay? A bottle of water is very simple. You got the plastic, you got a label, you got the water, and you have a cap. Very easy. Very simple product. It's a low-cost product. I make millions of these bottles of water a year. They're all the same. Identical. Low cost. Make a lot of them. The process is automated and continuous. That's what process means. Continuous. It doesn't stop. I make 1 million water bottles a year. Okay? That's a lot of water. That's a lot of bottles. 1 million a year. Think about it. And 1 million water bottles, it's real easy. It's on an assembly line. it goes down automatically. It's automated. Got a machine that makes the plastic bottle, that crafts it, pours the mold, makes the bottle of the bottle itself. I got a label maker, puts the label on it. A filler puts the water inside the bottle, and a capping machine that puts the cap on it. And then it rolls down the line and ends up in a box. Okay? It's continuous. It's the same thing, same process. That's what process costing is. These costs, I can't trace these costs to a single bottle of water. Okay? That's almost impossible. Because on most days, I don't know how many bottles of water I'm going to make. I can tell you the same exact thing. So I use a process to apply the cost. Repetitive. And at each step of the process, I apply direct materials, labor, and overhead. Those costs move with the product as it's moving down the assembly line to become a finished good. So last week we talked about job order costing. We know that a job order is unique to the customer's order. Use the example of manufacturing a car. We had direct materials, direct labor, and factory overhead that went into making each car, each step of the process. Ultimately became a finished good. Process costing still uses direct materials, direct labor, and factory overhead. The difference is we add all of those costs into each department as the product moves through the process. Here we have an example of a tennis ball manufacturer. When I manufacture a tennis ball, it goes through a process. First, I mold the core. And then I cover the core in a felt material. Then the felt material gets cut and glued to the core. Then it moves into packaging. It gets put into a package. And it moves to become a finished good. Tennis balls, there's millions of those, right? Maybe even billions. The process is the exact same, and it's continuous. So that's what process costing is. That's what we're going to talk about. In tennis ball manufacturing, tennis ball moves through several departments. First, the core of the tennis ball is made using rubber. That's the first department within work in process. What I do is I transfer my raw materials into work in process. And I add in my direct labor. I add in factory overhead. Those costs, direct materials, direct labor, factory overhead, start in the core department. Once the tennis ball core is made, the core moves to the felt department down the conveyor belt. As the tennis ball moves from the core department to the felt department, the costs move with it. I need to transfer out the cost from the core department, move along with the tennis ball. So to do that, I debit felt department work in process inventory, and I credit core department work in process inventory. What it does is it's transferring the costs from the core department to the felt department. Within the felt department, that middle piece here, I'm going to add an additional direct materials, which is the felt. I'm going to add an additional direct labor, the employees doing the gluing. I'm going to add an additional overhead, the machinery, electric, etc. Once I've added those additional direct materials, additional work, direct labor, additional overhead in the felt department, I've added that to the cost that Ball incurred in the core department. Then I can transfer it out to packaging. And to do that, I debit work in process packaging department, and I credit work in process felt department. That's transferring tennis ball down the conveyor belt to the packaging department. And in the packaging department, finished product, the tennis ball, is being put into a package with other tennis balls, in some type of package. And then that package is the finished good. So I debit finished goods inventory and credit work in process packaging department. But it's also important to know that in the packaging department, I've added in additional material, the package, additional labor, people putting the packages together, and additional overhead. So you can see that at each department, I've added in additional direct materials, additional direct labor, and additional factory overhead. So we're going to talk about this concept called equivalent units of production and how we use this in process costing. Equivalent units of production is the number of units that could have been started and completed during the accounting period, given the costs incurred during the period. What this means is, according to the matching principle, I'm accounting for all of the costs from start to finish that could have been completed during the month. So what we mean by equivalent units of production. The key word here is could have been. Could have been. Not necessarily completed, right? In order to account for equivalent units of production, we take the number of physical units and multiply that by the percentage complete. Percentage complete. Here we have an example where we have 10,000 tennis balls. And I've used all the material. That's 100%. Each tennis ball, I've applied 20% labor. That's 20%. And for each tennis ball, I've applied 20% of overhead. Similar to our earlier examples, the overhead is a predetermined overhead rate. In this example, it's 100% of direct labor. The direct labor being 20% in this case, that also means we have 20% overhead. That's where these percentages are coming from. So we take the number of units times percent complete. Direct materials, 100%, so that's at 10,000. 20% for direct labor is 2,000. 2,000, of course, is 20% of 10. Same for overhead. Inventory or manufacturing, it's important that when we're manufacturing that we're tracking the cost of our inventory. And similar to what you learned, Principles of Accounting 1, we have to decide whether to use weighted average or first in, first out method. Weighted average, as you may recall, includes all of the purchases, in this case, all of the inventory that we've created. Add all of the individual purchases or inventory together and divide by the number of batches. That gives us the weighted average. First in, first out, or FIFO, as you remember, is when we sell the first batch that we've created. Okay, first in, first out. So we have to figure out which of those two methods for our inventory or production works the best. And so we're going to go through each one, weighted average and first in, first out. So first, let's talk weighted average. Remember, weighted average, we're adding up the individual batches that we've created and dividing accordingly. So how do we apply weighted average to process costing? First step is we figure out the physical flow of units. If we think about our tennis ball example, tennis ball starts with a core department, then the felt department, then the packaging department, and then it becomes finished good, right? It is the physical flow of tennis ball. Most moves through those three departments. So first one, determine physical flow. Step 2, compute equivalent units of production. Now, as we just learned about with equivalent units of production, it is based on the number of units that we could have completed during the accounting period. If I expected to complete 10,000 tennis balls during the month, 10,000 is my units that I could have completed. I multiply that by percentage complete. If I use 100% materials, 100%, 20% labor, 20% factory overhead, those are my equivalent units of production. So it would be 10,000 plus 2,000 plus 2,000. That would be 14,000 units. I compute the cost per equivalent unit. It's usually something like 14,000 units divided by the total cost, right? Get the equivalent cost per unit. And then step 4 is assign and reconcile the cost. So step 1, determine the physical flow of units. Here we have an example. I don't know exactly what we're making here. Something fun. I see roasting. I see blending. I don't think they're tennis balls. It could be. Let's take a look here. Conveyor belt, right? First, of course, everything starts with the employees. Employees come through the front entrance, they clock in, and they get to work. Of course, everything else starts with raw materials. Raw materials come in from the loading dock, and they get stored in the storeroom. Now I'm ready to get to work. We start with what appears to be the roasting department. The product starts in the roasting department, where I add raw materials, direct labor, and factory overhead. The product moves down the conveyor belt. You can see it moves into the blending department. In the blending department, I'm adding in additional materials, additional direct labor, and additional overhead. Overhead coming from the machinery, direct labor coming from the more employees on the assembly line, and more direct materials. And then it moves toward the end of the line, the packaging. The product gets packaged, set aside, and moved out to the loading dock. The packaging, I'm adding additional direct materials, additional labor, and additional overhead. Then we sell the product, put it on a truck, and move it out. This is the physical flow of process manufacturing. It's continuous, the same exact product over and over again, high volumes. And this is the physical flow of it. But we can see at each department, we're adding in additional materials, additional labor, and additional overhead. So, the second step of the operation is we got to figure out the conversion costs for equivalent units of production. Okay. So typically, to figure the equivalent units of production, I take 100% of direct materials. I'm using 100% direct materials. And as the product moves through the physical flow, I'm converting the cost. That's what conversion cost means. Think of conversion costs as how far down the assembly line did the product get? Because remember, in each department, I'm adding in materials, direct labor, and factory overhead. When it moves from the first department to the second department, I've converted those costs over to the next department. That's where the word conversion cost comes from. So here we have an example. We ended the month of March with 30,000 units. Remember, to find equivalent units of production, it's based off of the number of units that I could have completed during the accounting period. In this case, the accounting period is the month of April. So I ended March with 30,000. That means I begin April 1 with 30,000. I also already had inventory in that second department, 90,000 units. So 90,000 units I started the month of April with, plus the 30,000 units I ended March with, gives me 120,000 units I could have finished in the month of April. I take my 120,000 units, I subtract out what I already completed during the month of April. I already completed and transferred 100,000 units in the month of April. So 120 minus 100 gives me an ending inventory balance of 20,000 units at the end of April. We can see this equation balances, yeah? So I need to find, based off of these equivalent units of production, 120,000, the conversion rate. To find the conversion rate, I take 100% of direct materials and identify how much of those units have been converted. In other words, transferred to the next department. So, looking at this, at the beginning work in process inventory, end of March, 30,000 units. I use 100% of direct materials. I have a 65% conversion rate. In other words, I've completed 65% of that beginning work in process inventory in the month of April. The units completed and transferred out, 100%. They're done. So when it's done, that means I've used 100% materials and 100% conversion. It's done. Ending work in process inventory, 100% materials used, 25% conversion rate. So now that I've found the conversion rates, I can find the equivalent units of production. To do that, we take the direct materials costs plus the conversion costs. We find conversion costs, we take the conversion rate, and multiply that by the units. So in this example, 81,000 plus 108,900 gives me March 31 total costs of 189,900. During the month of April, I've added in additional direct materials costs, additional labor costs, and additional factory overhead using the factory overhead applied rate. The overhead applied rate is 120% of direct labor. Direct materials plus direct labor plus factory overhead of 120% of direct labor gives me total cost during the month of April of $655,200. The month of April, this gives me a total production cost of $845,100. Questions? Doing okay. Oh, good. Right. Oh, thank you. Okay, so let's walk back through the process. Step 1, determine the physical flow of units. Starts beginning inventory, go work in process, a couple of steps in work in process, and then becomes finished goods. Beginning work in process plus units started during the period gives me equivalent units production, 120,000 units. Step 2, compute the equivalent units of production. Number of whole units completed and transferred out of the next department plus the number of equivalent units ending work in process inventory. Now is 120,000 units, equivalent units of production. We also find our conversion costs, 100% direct materials, 25% conversion. 25% of 20,000 equivalent unit production is 5,000 conversion cost, giving us total conversion cost of 105,000 units. Step 3, we compute the cost per equivalent unit. We add up all of our costs to get our total costs, so beginning work in process plus cost during the period, to get total costs. We find the total cost and divide by the equivalent units of production from step 2. Equals the cost per unit, or equivalent cost per equivalent unit, sorry. Do the same thing for both materials and the conversion costs. And step 4, we assign and reconcile the costs. Direct materials plus the conversion costs equal the cost of units completed during the period. And of course, we add in our direct materials and conversion costs for the ending period of the period. Gives us total costs accounted for. I like this one. I like this slide because it helps us to summarize those 4 steps in a nice, graphical, meaningful way. I would totally use this slide to assist you with the homework assignment. I think it will help. Hint, hint. Use this slide for the homework assignment. It will help you. I think it will anyway. But yeah, this is cool. I like this one. Shows those 4 steps in a nice graphical way. Here's some additional cost data for our company. We have raw materials inventory of 100,000. We got beginning work in process inventory for our 2 departments, roasting department and blending department, plus purchases that we've made. And then we add in additional purchases or requisitions. We add in, of course, our direct labor and factory overhead. These are all of our costs. Let me show you how to record those costs during the flow, the physical flow. So remember the physical flow. We started in the roasting department, and then moved into the blending department, and then ultimately the packaging, etc. Right? At each department, add in materials, labor, and factory overhead. Okay. So there's a couple of transactions. First transaction is I purchased some raw materials. So debit raw materials inventory, credit accounts payable. Cash, depending on how you pay for it. The second entry is I'm going to use those raw materials to start production. So I'm going to debit work in process inventory roasting and debit work in process inventory blending. What this does is it moves the raw materials into these 2 departments. Of course, it's after it's gone through roasting. Does it get to blending? Of course, the third step is to apply your factory overhead. Because remember, at each department, we have materials, labor, and additional factory overhead. It keeps kind of like adding up and adding up and adding up until it becomes a finished product. It's the physical flow. We do the same thing for labor. labor in each department. We debit work in process inventory roasting and blending. And we credit factory wages payable. This shows the accrual of the labor for the employees in those two departments. And we add an additional factory overhead by debiting factory overhead, credit factory wages payable. And then, of course, we pay our employees. And for the overhead part, we add in our overhead for each department. How do we do that? We figure out our total factory overhead and we allocate it accordingly. Debit factory overhead, credit all of our various things. Insurance, payables, depreciation, utilities, etc. Right? And we apply our factory overhead by taking that total amount and debit work in process for each department and credit factory overhead. This kind of shows you how we apply cost for direct materials, direct labor, and factory overhead to each department as it moves down the line. Right? As the product that we're manufacturing, like the tennis ball, for example, gets transferred from department to department as it moves down the conveyor belt, we need to record the transferring of that product, that unit. The unit starts as a core. The core is molded. It gets transferred to the felt department. As it's being transferred, I'm also transferring the direct materials, direct labor, and factory overhead that I incurred in the core department. So I'm transferring the physical unit along with the additional direct materials, direct labor, and factory overhead that were incurred with the ball in that department. That gets transferred to the felt department. In the felt department, I'm going to do it again. I'm going to add in more materials, the felt. I'm going to add in more labor, the people gluing the tennis ball together. And I'm going to add in more factory overhead. And then it's going to get transferred to the packaging department. We do the same thing again. Right? So I'm going to show you how those transfers work. So our other example, we have the two departments, roasting and blending. I'll show you how the units get transferred from one department to another. We debit work in process inventory blending, credit work in process roasting. What this does is it represents the transfer of 100,000 units from the roasting department to the blending department. Then, once it's done in the blending department, it becomes a finished good. So we debit finished goods inventory and credit the blending department to record the transfer from blending to being a finished good. Then when we sell it, debit cost of goods sold and credit finished goods inventory. You can see the transfer process. It's similar to, I think it was maybe 2 weeks ago, we were talking about the physical flow of the car when we were manufacturing the car, how it went from raw materials to work in process to finished goods. It's the same thing. The difference here is that in process costing, we're looking at the application of those costs on a department basis within work in process. So it's kind of like you take a microscope, right? And you zoom in real close like on the work in process part. And that's what we're looking at today. Yeah, it's like individual departments within that area. A couple of trends that have been happening within work and process operations: more robotics, more automation, surrounded by customer service, additional services, process design, yield, continuous processing, and just-in-time production. Think about a facility that manufactures water bottles. They shape the plastic mold of the bottle itself. Mold then goes down the conveyor belt with millions of other bottles to the filling department. It gets filled with water. Then it moves on to the labeling machine. A label gets put on it. And a cap goes on the top, the capping department. And then it moves into packaging department. Right? And it's all automated. It rolls down the conveyor belt by itself. Machines do all the work. The humans are there to supervise the work that the machines are doing. It's a continuous process improvement. It follows a process design. It's robotic in nature. So these are the trends in process costing. You can have a hybrid cost system where we take elements from job order costing and process order costing, bring them together. We can make a whole lot of the same car and just distribute those to our dealerships. Example of that would be Chevrolet or Ford, General Motors. They make a lot of the same car. And they send those to various dealerships around the world, right? Same exact car, same color, same everything, same specs, same engine, same everything. They make a whole ton of them. It's based on the customer's order. So that represents a system that uses both process and job order operations. That would be your Chevrolet, your Ford, your General Motors. They make the same exact thing over and over again. It's highly standardized. It's meeting the customer's needs. So that's an example of a hybrid cost system. Would be your Ford, Chevrolet, General Motors. It's different than the example we talked about last week with Toyota. Toyota is very specifically based off of job order costing. You do just in time, it's highly specialized, not always the same, customizable, etc. But the hybrid system is what mass producers of automobiles use. Yeah. Okay. So we talked about weighted average for the inventory using equivalent units of production. Now I want to talk quickly about first in, first out, which is very similar to the first in, first out that you learned about in Principles of Accounting 1. The difference here is we're applying it to process costing. So as you know, first in, first out, we take the first cost information is the cost that we use, right? First in, first out. So here we have some data. We have units of production, 30,000 units, direct materials, 100%, conversion costs of 65%, direct materials 81, and conversion costs are 1089. Okay. That's March 31. During the month of April, we started an additional 90,000 units, and during the month of April, we transferred out 100,000. We added some additional costs of direct materials, direct labor, and factory overhead during the month of April. At the end of April, we ended with 20,000 units ending inventory. 100% use of direct materials, with 25% units being converted from, to finished goods. And so with this data, we can get the first in, first out method. Step one of using the first in, first out method is to determine the physical flow, just like we did with the weighted average. Beginning work in process inventory plus units started during the period, giving us 120,000 units. Let's take units from the beginning inventory plus units started in the period, 1,000 units on the other side, plus ending work in process inventory, also 120,000 units. The two equal. Second step, find the equivalent units of production. As you know, the equivalent units of production are calculated by the number of units that are expected to be started and completed during the accounting period. In this example, it was 90,000. How we got there? We have equivalent units to be completed at the beginning of work in process. Materials was 0%, so 0. Conversion of 35%. The conversion on the conversion side, that'd be 10,500. Equivalent started and completed during the month of April. We had 70,000 units. Equivalent units and ending work in process during the month of April was 20,000, giving us equivalent units of production of 90,000. Units converted are 10,500 plus our 70,000 equivalent units started and completed during the month of April, plus our converted units at the end of the accounting period, 5,000 in this example, 25% of 20. Giving us converted units, equivalent units of production of 5,500. Using the first in, first out method, we take the total costs incurred divided by the equivalent units of production to equal the cost per equivalent unit of production. And step 4 was to assign and reconcile costs. Beginning work in process inventory plus the cost to complete beginning work in process plus the cost of started and completed during the month of April plus the cost of ending work in process inventory to get us a total cost of accounted for 845,100. So we can see the difference between first in, first out, and the average. Being work in process plus the direct materials and conversion plus direct materials and conversion equal total cost accounted for. That's the primary difference between first in, first out and weighted average for equivalent units of production. But, you don't have to go too deep on that part. The parts of that chapter that we just talked about that I really want you to take a lot into consideration are, of course, equivalent units of production. Yes, it's important. but I also want you to understand the physical flow. Remember that with continuous process, it doesn't stop, right? It's continuous. So we're at each department within work in process, we're adding in additional direct materials, additional labor, additional overhead, adding up, adding up, adding up. At each department that the product moves through until it becomes finished good. That's the takeaway. That's what I want you to really understand from this concept of continuous, process costing. Are there any comments, questions, or concerns? Anything I didn't answer as it relates to process costing? Sorry, are we good? What's the thumbs down for? Is that not good? Did I not do a good job?
No, we're good.
We're good? Thanks, Christian. Zario, did I do okay or no? Good job. Okay. Got nervous. I saw thumbs down. I'm like, what's this? Thought we were friends. What's up with that? Oh, that's funny. I'm just kidding. Cool. So just to kind of repeat what I had said earlier, just in case you missed it. If for whatever reason you were late with something, maybe it escaped your mind that Chapter 19 assignment was due this past Sunday, I need you to get that done. Okay? Please get it done. If for whatever reason you decided to skip the discussion that was worth 10% of your total grade back in Chapter 17 a couple weeks ago, I need you to get that done. Because if you miss something in this class, it's going to cause you not to pass it. Okay? And if you don't pass, that's not good because then you got to see me again. So I need you to pass. If you pass, you do all the work. Make sure that just go back, okay? Just check the past 4 weeks. Make sure you didn't miss anything. Maybe you accidentally forgot to click submit or whatever. But I just need you to just double check. Make sure that all your work is done. Okay? You got to do all the work to be able to pass. It's that simple. All right? Any questions on that? Comments? Anything? Okay. Right. Well, listen, I appreciate all of your hard work. I do. It's really important to me, and I'm sure you can see it's important to you. So let's talk about Chapter 20. We have a Chapter 20 quiz. Same as before, 5 questions, true, false, multiple choice. Try to take your first attempt at the quiz on Thursday, okay, during class time. Thursday during class time, take the Chapter 20 quiz for the first time. If you don't do so well, it's okay. You can do it again, right? You got 2 attempts. It's the same with any other quiz or homework assignment. You got 2 attempts, all right? Just try your best, But I just want to say I really appreciate all of your hard work in this class. I know it's a lot, especially with your other courses, and you got work and family and all that jazz on top of it. I appreciate it. I do. I see your hard work, and that means a lot to me. And if you ever need help, you can always email me. You can call me. You can set up office hours. Whatever you need. I'm here to help you out. Your success is really important to me. I'm here for you. I am. So with that, I appreciate all of you. I want to remind you to stay safe, wash your hands, do the right things, and I'll see you all again next time. I appreciate you. Have a wonderful rest of your night. Thank you so much. Bye-bye.